Okay, here we are, Stats and Mechanics, Year 1, Chapter 11, Question 12. Okay. A mouse leaves a hole and makes a short journey across a straight wall before returning to its hole. Mouse is a particle moving in a straight line. The distance of the mouse S from its hole at time t minutes is given by, alright, so the distance that this mouse is S equals t to the 4 minus 10t cubed plus 25t squared. Okay, and this is for in between 5 seconds. Okay. Explain the restriction of 0 to t seconds. Okay. Well, I'm guessing that 0 and 5 are probably roots of this, one way or another. So if we were to quickly look at this, explain the restriction of this. Well, if we were to look at this and just take out a, we can take t squared out as a factor. We can, okay. So if we take t squared out and say t squared minus 10t plus 25, okay, we can factor in this again and say that t squared is, let's factorize that quadratic there. 5 and 5 is 25, so let's go with that. T, 5 and 5, both minuses. So when we factorize this out, we get, and if it was to set it to 0, we are getting t equals 0, t equals 0 twice, and then t equals 5 twice. Was that correct? Yeah. Okay. So considering this is a W-shaped graph, okay, something like that, okay, it's basically very flat on its bottom, and so it's just coming through like that, and it must be, is it that way around, or maybe it's the other way around. It shows that there's only positive values. It must be the other way around. So that it comes through here at 0 and 5, and so its distance S is only in the positive realm between 0 and 5 seconds, okay, as this thing wobbles through. So it's only valid between here and here in essence on it, okay, for 0 and 5. All right. Can I look at that on a graph to explain it better? There's a bit of Desmos. Will this display up? I don't know if it will. No, it's not. Can I turn on that? Okay, so if we turn off this, we can see that. So if we turn off this one, we change it into Desmos mode. Here we are. And so by putting in that equation of t to the power, not t, but x in this, x to the power 4 minus 10x cubed plus 25t, 5t squared, but it's an x. Okay, so you can see there between 0 and 5 is the only places that it gets a positive value. Okay, so it's modeled like that. Okay, so it's just where it is for those points on there. Okay, and because they were both squares, they just touch like it's shown here. Okay, so how are we explaining this in its entirety? Right, so we need to say that the graph only gives positive values for S in the realm of 0 to 5 seconds before t equals 0, we are in negative time, so can ignore. And after t equals 5, the values only ever increase, so not a practical model. Okay, so basically the whole thing is looking like that, and so it's only valid between there and there, the 0 and 5. Okay, right then, model. Right then, part B, find the greatest distance of the mouse from its hole. Do this on site almost. Right then, so when the slope of this graph is when the ds by dt at this point is equal to 0, we will have the greatest slope. That's also going to be here and here, but in short, we want to do ds by dt. Okay, so we are going to be doing, where is it? 40, let's just come down here, is going to become 4t to the cubed minus 3 times 10t to the square plus 2 times 25t squared, not squared but to the 1, which of course is equal to 4t cubed minus 30t squared plus 50t. Let's set it equal to 0 and start factorizing it out. So 0 equals t 4t squared minus 30t plus 50. I suppose we should take a 2 out of that as well. So 0 equals, let's divide it all by 2 and t. We end up with 2t squared minus 15t plus 25. Okay, dividing by 2 and dividing by t. And now we can put that into the solver. Okay, so t equals and t equals, one of these will be 5 or something, I think. So polynomials to a degree of 2, because we've done the whole thing, I suppose. 2 minus 15 plus 25. One of them is 5 as expected, and one of them is 5 over 2. Okay, the other one would have been t equals 0. So t is there, so now we just need to put that in. S equals, what was the original equation? over 2 to the power 4 minus 10 times 5 over 2 to the power 3 plus 25 5 to the power 2 squared equals, since I've still got graph drawn on Desmos, I'm just going to read it off there, 39.0625. 39.0625. Okay, meters I think we were working in. Yep,